Hello, everyone, and welcome to today's lesson of weighted averages. Okay, that was corny. Let's go. So, weighted averages is a set of data, is the sum of the product of the number of units. This is a big, long thing. Yes, you do need to write it down, but what it really means is it's like a grade where each column is weighted differently. And we'll get into more of that in a sec. So, it would look like this. If you got 90%, let's say this is your notes. And this is tests, and this is homework, more traditionally. So between those three things, those are what they're, I got 90% in notes, 70%, yeah. So I would then change those into all decimals, because you can't multiply a percent. Multiply those percents, or those decimals together, would come out to these three numbers. From there, I would then add them all together. This means I would get an 81.75 in the class. That's what that would actually mean. So a little bit more on weighted averages. You could have taken, for example, let's say this is your normal tests. This will be test 1, test 2. Let's call this a pre-test, I don't know, and then a final. So those are the three, and that's how they're weighted. So you would take the score of each one by however much they're weighted. So each test is worth a little bit more on the last two, so you'd multiply by that by the weight. And then you'd add them all together, and then you divide it by however much the weight added up to be. So that's how we'd come out with 81.43 is what this person would have averaged with a score of this with a weight of this. So in this class, notes are weighed at 15%, videos are 15, classwork is 35, tests are 35. So if let's say you get a 90 on the notes, 75 on the video. And let's say you get a classwork. Everybody's got to get 100 because you can correct it as much as you want. And then let's just say you bomb all the tests. What would your grade be? Come into class tomorrow, figure this out in your notes, and I will have a prize for you if you figure it out. Okay, so a mixture problem. Two or more parts are combined into a whole, and that is solved using weighted averages. So my coffee this morning, I had 2 parts cold brew. Oh, it was so good. It's my first one with 1 part milk. So a uniform motion problem. This is more commonly known as problems where they have a speed or a rate. Most of the time, you're going to use D equals RT, and that's distance equals rate over time, or times time. All right, so we're going to get into some examples here. So Jerry feeds her cat gourmet cat food, and that costs $1.75 per pound. She combines it with the cheap cat food that costs 50 cents a pound. How many pounds of cheaper food should Sherry buy to go with 5 pounds of gourmet food if she wants the average price to be $1 per pound? So we're going to let W be the pounds for each one. So we have units. So we're going to say there's 5 pounds of cat food. We need to know how many of the cheap cat food, and then the mix is 5 pounds plus the other one. So that's how you come up with those numbers. So price per unit. Well, they said $5 pounds of $1.75. We don't know the weight or how many of these, and we want it to average out to a pound per unit. So we're actually going to multiply these two together, would equal, whoops, getting ahead of myself. So those are going to equal this. Multiply those together is going to equal that because you can't do anything with it. And these two are going to multiply together as well. Well, we put that into a problem then. So we say this one plus this one equals this one. So the price of the gourmet cat food plus the cheaper cat food equals the price of the mixed food. So after we multiplied them by 5 and multiplied the number by 5, multiplied that by the weight, and then the weight times, or the desired price times however much we have and how much we need to get. Now we've just set this into a, just like yesterday's, things with 2 sides. So now we've got a variable on both sides. Remember, it doesn't matter which direction you go, you just got to move them. So we're going to first distribute them. Distribute. Go like that. Then we're going to subtract 5W, or 0.5W is what they did. You could go either way. Subtract that from both sides. Simplify that out. We're going to go to the other side, but we're going to actually subtract 5 from both sides. Subtract 5.0 from both sides. Simplify that. Divide by 0.5. Simplify. Now we say she should put 7.5 pounds of cheaper cat food to equal those. Pause this, give it a shot. Okay, so we would need 3 ounces of glass beads, cost this much an ounce, and seed beans, so glass seed, cost 99 cents. How much of those would we need to do to have that? So we know that we have 3 ounces of one. We don't know the other one, so let's call that beads. Why not? Beads, and then we want it to be B plus 3. So this one we have 179. This one we don't know. Or this one costs 99. And this one we want it to cost 129. So we multiply, multiply, multiply. Put it in a this one plus this one equals this one. So that would look like 537 plus 99b equals 129, and then b plus 3. From there, we would distribute these over. So that would be, what's that, 1.29. 1.29b plus, looks like 387, 3.87. Yes, I did that in my calculator. And we'd actually bring all these down. So 5.37 plus 99.99b equals that. Don't forget those decimals. I struggle with that sometimes. Okay, from here, we're going to take this one this direction. So I'm going to subtract 99 b's, and I'm going to subtract 99 b's. And those will cancel. This comes out to 0.3 b's. And I'll bring down everything else, 3.87, 5.37. From here, I'm going to subtract 3.87, subtract 3.87. Those cancel, because it's all equals here. Equals that. That comes down to 1.5. Hey, it's going to come out evenly. 0.3 b's, divide by 0.3, divide by 0.3. And that comes out to 5 ounces. 5 equals B. So we'd say 5 ounces would be my answer. The hardest part about this is getting it set up. And I really do recommend using this here on the first thing, where you have how much of it times how much of it times how much, and then those two together times the desired price. That's going to be your big key. All right, percents. A car's radiator should contain a solution of 50% antifreeze. Daryl has 2 gallons of 35% antifreeze. How many gallons of 100% antifreeze should Daryl add to produce a solution of a 50%? This looks different. It's really the exact same thing. You're just using a percent instead of a price. So we're going to let G be the solution. So we have 2 gallons of 35%, so we have a 35% solution, and we're going to multiply that together. We have a 100% solution, and we don't know how much of that we need, and our desired solution is 50%. So we'd have 2 plus G to get those mixed together. So 100% would be 1, 35% would be 3, and then 50 times 2 plus G, because we need to mix those together to get this. So those are the 3, and it's going to be this plus this equals this. Same process that we had just a little bit ago. So the 35% solution plus the 100% solution equals a 50% solution. So then we're going to multiply those out. Sorry, first we're going to distribute on the right. So first distribute. Distribute that first. We're going to subtract 0.50 G from both sides. These two cancel. That's going to turn into 0.7 plus 0.5 G, because remember, 1 minus 0.5 equals 0.5. From there, we're going to subtract 0.7 from both sides. And then we're going to divide by 0.50, which will turn this into 0.60, which would make sense, because when you divide by 1/2, you technically multiply it. So that's how that goes out. And so we would need to add 0.6 gallons of 100% solution to produce an exactly 50% solution. Spoiler alert, it's not that big a deal. It just needs to be 50% solution, as close as you can get it. Pause this, give it a shot. Right, so we're going to set this up over here. So I have 50% solution, and I have a half pound of it. So I'm going to say 0.5 to make it easier. 0.5%. We have a bunch of 75%, so 0.75 needs to be added of peanuts, P, required to make a 50% mix. So I'm going to need to go 0.5 plus P in order to get this. And I need to make a 50% mix. So we multiply all these together. It's going to be this plus this equals this. And these would all be multiplied. So that's going to come out and look like this. 0.5. Wait, did I do this right? Yes. 0.15, 15%, not 50%. That's why they didn't like. 0.15 times 2, or sorry, times 1/2 plus 0.75p equals 0.5 times 1/2 plus g. Okay, we're going to distribute these over, so that comes out to 0.5 or 0.25g, or 0.25 plus 0.5g. Just multiplied, punched them into my calculator to get that. And we're going to bring these down. And then multiply these out really quick is going to be 0.075. Because that's half of 15, or 0.15. Okay, here's where it gets a little bit confusing because we're going to have some negatives no matter what we do. So I'm going to take the p's over first. 0.75p minus 0.75p. These cancel. So that would come out to negative 0.25p. And I'll bring down this 0.25 equals 0.075. I'm going to subtract 0.25 from here, subtract 0.25 from here. Remember, that's how those would actually line up. Those would cancel. That comes out to 0.7. Yes. 1.75. There we go. Negative 175. There we go. So that comes out to, ignore that, equals negative 0.25p. Divide that by negative 0.25, negative 0.25. These will cancel, and this will come out to 7/10. So 0.7 would convert to, if I put that over 10, 7 over 10. And there's my answer. Oh, I gave you the answer early. Lucky you. Keeping going. All right, air travel. Marisol took a nonstop flight to visit her grandmama. The 750-mile trip took 3 hours and some odd minutes. Because of bad weather, her return took 4 hours and 45 minutes. What was her average speed round trip? Okay, so this is going to use the average of speed for each leg. So we're going to rewrite this by dividing both sides by t to get r by itself. So all we did was divide by t, divide by t. These canceled, and that's how we turned it into that. So for there, we're going to say on the way to one direction, she went 750 miles in 3 hours and 75 minutes, 3.75 hours, because we took this 45 minutes, an hour, 60 minutes, just 3/4. Anyways, moving on. Keeping going. So on the return, we're going to go 750 miles. It took her 4.75 miles, so it's 157. So to get the average weighted bit here, now the weight is going to be here, and here's the times. Because it's just like our weighted one earlier where we multiplied it by how many they had, how much the weight was. So 200 and then 57.9. Come add those all together, or times and add on the top. and then add them the bottom together. So these come out to this, and this came out to this. Divide that together would be 176.5. So we'd have an average speed of 176.5 miles per hour. Pause this one, give it a shot. Okay, so we have a 30-minute trip, and it took them in 15 miles, or 15-mile trip in 30 minutes, and a 15-mile trip in 45 minutes. Well, let's find the average trip of each one first. So I'd take my 30, so in 15 minutes, or sorry, he went in 15 miles, we go 0.5, sorry, my apologies. So you'd have this 30 minutes. We have to think about this 30 minutes in terms of an hour. So in 30 minutes is half of a 60-minute hour. So we're actually going to convert that to 0.5, just like in the last problem. And 45 minutes, we're going to convert that to 0.75 of an hour. So that gives us our time. So we have our distance equals rate over time, which we converted in the last one to rate, because that's what we're looking for, equals distance over time. So we're looking for D and time. So our distance is 15 divided by 0.5, and our second distance is going to be 15 over 0.75. So this comes out to 30 miles per hour, and this one comes out to 20 miles per hour. From there, we want to take these numbers, multiply them by the rate, or multiply them by, the length of time, and we're going to put that over the total time of both directions. So I'm going to go 30 times 0.5 times, I'll just make that a little easier, plus 20 times 0.75, and that's going to go over 0.5 plus 0.75. From here, we punch all this into our calculator, or you can distribute it however you want to do it. It comes out to 0.24 exactly. All right, I know I'm getting long, so we're going to try to do these as quickly as possible. A railroad switching operator discovered that two trains are heading towards each other in the same track. Currently, the trains are 53 miles apart. One is traveling at 75 miles per hour. The other is traveling 40 miles per hour. The faster train will require 5 miles to stop safely, and the slower train will require 3 miles to stop safely. How many minutes does the operator have to warn the train engineers before they need to stop their trains so we don't have a crash? So the easiest way is, let's start with a diagram. So we have train coming from the left that takes 5 miles to stop, train coming from the right that needs 3 miles to stop, and they are currently 53 miles apart. So at the point where they're 8 miles apart, the engineer better know, or they are going to crash. So 8 miles less than that means 45 miles left is what we need to know. So we're going to have distance, rate times time. So the rate of 75 less rate of 40. The time is the same. Distance equals rate times time gives us those two. So write and solve an equation for the information in the table. So the distance traveled plus the distance of the other travel equals 45 miles. So this is all in the setup. If you get it set up, you guys are going to do just fine. So we write the original equation, we add them together, then we divide both sides by 115, would give us 0.39 when we round it all up. So we multiply that by 60 because 0.39 of an hour doesn't make any sense to us. So 23.4 minutes, about 23 minutes to warn the engineers. All right, pause this one, give it a shot. Okay, two students left the school on their bicycles at the same time, one heading north, the other heading south. The one heading north is going at 15 miles per hour, and the one going south is going 17 miles per hour. How many minutes until they are 7.5 miles apart? Okay, well, we have to use distance equals rate times time. Well, the time is going to be the same, so we're going to call that t. So time times 15, time times 17. So I'd have 15t and 17t. And I need to go until they're a distance. Well, yeah, so the distance we know is 7.5 miles. From here, we combine like terms over here. So that gives me 32t equals 7.5. We divide both sides by 32. Divide by 32, divide by 32. Those cancel. Would give me a t equals 0.234 or so, approximately. And that's not a number we can use. Remember, we have to know it by times. So we times this by 60. So 0.234 times 60 to give us minutes. And that comes out to approximately 14 minutes. I came out with like 14 point something, 0.0 something. So 14 minutes, close enough. Moving on.